Hello everybody, this is Dr. Christopher White, and in this video we're going to be looking at the formation of coal and coal bed methane. So like petroleum, coal is considered to be a carbon-based resource. Now it is considered to be separate from petroleum. So petroleum and coal, they have different starting materials, they have different processes, and obviously the end product is different. So they are considered to be distinct from one another. So what kind of environment are we going to be forming coal in? So coal is going to require large amounts of plant material. So we're going to need to start with some kind of environment that's very, very rich in plant life. And we are also going to need that plant life when it dies to enter an environment which is relatively low oxygen. And so the kind of environments that we're going to be looking at are going to be swampy environments. So you've got lots of plant life, and when that plant life dies, it's going to fall into the water, and the water it's falling into is relatively oxygen poor. And of course, that's going to inhibit decomposition. This is going to allow the plant material to build up at the bottom of our swampy environment, and steadily over time, that plant material is going to form a solid layer of organic material. In terms of the types of environments where we're going to find these kind of swampy conditions, we are looking at continental and coastal environments. Coal deposits do not form in marine environments, so we're looking at swampy environments typically located near coastal regions. So think of somewhere like the Florida Everglades would be a good example of this. So in these environments, we're going to have lots of plant material, and that's going to fall into water, and its decomposition is going to be stopped due to the low amount of oxygen. Now, when that plant material falls in, it's going to contain lots of three main materials: cellulose, hemicellulose, and lignin. And these are very robust organic materials. They do not break down easily. And so in order to take them from plant material to very high grade coal, it's going to require quite high temperatures and quite high pressures. So this is another reason why coal is distinct from oil and gas, because you've got different starting materials and you require considerably different conditions to actually produce your end product. So in terms of the materials we're going to form from our organic material, you're going to see changes as the pressure and temperature increases. So initially, we have our plant material. It's going to die, fall into our body of low oxygen water, and it's going to build up as a layer in the bottom of our swamp. And steadily, as more and more material builds up on top of it, that layer of organic material is going to get compressed, and it's going to form essentially a solid block of undecomposed organic material, which is referred to as peat. Now, as our layer of organic material gets buried deeper, it's going to experience higher temperatures and higher pressures. And steadily, this is going to lead to the peat converting to a new form, which is called lignite. As the temperature and pressure increases further with even deeper burial, we're going to move from lignite to bituminous coal. And then as it gets buried even deeper and it experiences higher temperature and pressure conditions, eventually that bituminous coal is going to turn into anthracite. So when we're talking about coal, we're actually talking about these four different types. We have peat, lignite, bituminous coal, and the temperature and pressure experienced by the coal is increasing as you move from peat to anthracite. And this increase in pressure and temperature is very, very important, because cellulose, hemicellulose, and lignin are molecules that are, they're not just carbon and hydrogen. They also contain lots of nitrogen, sulfur, phosphorus. And so that means there are lots of chemical impurities within the organic material. So the higher the temperature and the higher the pressure that the organic material is exposed to, the more of those organic materials will essentially be, for want of a better term, burnt off, gotten rid of into the surrounding rock. And so as we move from peat to anthracite, we see the amount of impurities decreasing, and we see the coal becoming more and more carbon rich as the impurities are kicked out. Okay, so let's begin with peat. So peat, as previously described, is going to form in swampy environments. And so if we look at these two environments here, what we have is a very organic rich area, so lots of plant material, and the ground in which that plant material is growing is waterlogged, it's saturated. And so when these plants eventually die, they fall over into this water, and this water is low oxygen. So decomposition is going to be inhibited. And so the plant material is going to build up within these bodies of water. And as more and more material builds up, the material at the bottom is going to experience higher pressures. And so it's going to take that plant material and it's going to start compacting it down, form a solid layer. Now, peat itself is a mixture of partially decomposed plant material, and it typically contains about 20 to 40% carbon. And this is essentially the same amount of carbon as the original plant material. Now, the thing about peat is it's really, really cheap, it's abundant, and it's easy to mine. So you can go to areas of the world which were once relatively recently swampy. Those areas have drained, and you can just dig down and you can find these layers of peat, which you can then cut quite easily using just regular everyday garden tools. You can dig it out and then you can burn it. So peat is or has been traditionally used as a fuel for things like power generation in some cases, but it was mostly used as fuel for home hearths, so for burning in the home. However, over time, it has been replaced with higher quality coal-based products, so it's not really used very much anymore. Now, peat is very low purity, so it has lots and lots of impurities in it. Now, this means the peat itself contains a lot of additional nitrogen and sulfur compounds, and these are going to form a range of different chemicals when it burns. The other thing is that because peat is so water rich, when it burns, it means it's not going to burn cleanly. And this means there's also going to be lots and lots of particles produced when you burn peat. So if you've ever seen peat being burnt, you will know that it produces a lot of smoke because there's a lot of particulates produced by that peat being burnt. So peat is the first stage of coal. It was traditionally used as a fuel for the home. However, its use has dropped off significantly as higher grade coal products have become available. Now, if the peat gets buried deeper, it's going to experience higher temperatures and pressures, and it's going to transform into lignite. So lignite also is a relatively low carbon material. It typically contains somewhere between about 25 to 35% carbon, and it's about 75% water. And lignite is primarily used for power generation. So like peat, it's not really good for using in any kind of environment where you want something that burns cleanly. So using it in a home, for instance, would not be a particularly good choice. So like peat, lignite has high levels of impurities. So when it burns, it's going to produce lots of nasty sulfur compounds and nitrogen compounds, and it's not going to burn cleanly. So you're going to end up with lots of particulate. So once again, going to produce a lot of smoke. It's not going to be great for using, in confined areas like a house. Now, lignite forms from the burial of peat, and it's taken down to depths of between 100 and 1,500 meters. So it's exposed to temperatures of about 50 to 150 Celsius. Under most conditions and most settings, typically less than 100 Celsius. And these conditions are sufficient to compress the peat level even further, get rid of some of the water because of that compression. However, the temperatures and pressures aren't high enough to really remove those impurities. So all lignite is it really is just a more compressed version of peat. So you'll notice it has approximately the same carbon content as peat. So the thing that lignite is good for, though, is because it's been compressed further, it tends to form nice, solid, more easily mined layers. So lignite also tends to be located at relatively shallow depths because you don't need much material on top of it to compress the peat to form lignite. So all you have to do is strip off the overlying rocks and sediments that you don't want, and then you can get straight into the lignite and start mining it. Now, lignite itself, because it's so close to the surface and because it's not really useful for anything other than power generation, it's a relatively cheap material. And so if you are going to mine it, you need to mine it cheaply if you want to be able to sell it. And so open pit mining is the only way to mine lignite. You're not going to mine it underground. It wouldn't be cost effective. Now, because lignite still contains a significant amount of water, what you can do is you can take the pieces of lignite and you can actually compress them to form an even more solid piece of material, which is referred to as a brick. And these briquettes are more easy to transport. So you can see here, you can take the lignite, compress it essentially into a standard shape, which you can stack quite easily. And so it means you can move more of it more efficiently by things like rail. Okay, so if we take our lignite and we bury it even deeper and expose it to higher pressures and temperatures, we're eventually going to start converting our lignite into bituminous coal. So bituminous coal is considered to be the moderate or medium grade coal, and it contains between 45 and 86% carbon, which you have probably noticed is a significant increase in carbon content versus lignite. So why is this? Well, as it's experiencing higher pressures, it means that the lignite, or the organic material, should I say, is being exposed to much more compressive stress. And so that's going to help to push out a lot of that water which is contained within lignite. So we've gotten rid of all that water now. It's a significant proportion of it. Another thing that's happening is it's being exposed to higher temperatures. And this is going to help to get rid of some of those nitrogen, sulfur, phosphorus impurities. And so what's going to happen is, as the lignite gets exposed to higher pressures and temperatures, water gets pushed out and some of the impurities gets pushed out. And so this means the percentage of the carbon left in the remaining material increases. So we end up with a much more carbon-rich coal. Now, bituminous coal is primarily used for power generation, and it's also used to produce coking coal for steel manufacturing. It's not really used for residential uses, because even though it's a much purer form of coal, it still doesn't burn super cleanly. So it's still going to produce a lot of smoke through burning it. Now, bituminous coal is the most common type of coal which is extracted. And the reason for that is it sits in a nice intermediate position between the lower, more high polluting lignite and the more expensive, cleaner anthracite. And so it hits a price point where it can be used for power generation, but it's not too expensive and it's also not too polluting as well. And so bituminous coal is the main type of coal which is extracted for those reasons. Now, it's called bituminous coal because within the coal itself, it's also going to contain bitumen, also sometimes referred to as asphalt. And this is an extremely high viscosity hydrocarbon. So, it's a very, very thick, sticky hydrocarbon. It's part of the coal seam, and the formation or the process of taking some of the organic material and turning it into bitumen will also produce methane as a byproduct. And so this means that bituminous coal deposits are the main source for coal bed methane. Now, why is methane important? Well, methane, when it comes to coal mining, is dangerous. So the first thing is methane does not have a taste, it doesn't have a smell. And so if you are mining underground and you are mining bituminous coal, that methane can leave the coal seam and it can enter the mine. And because because there's no smell, there's no taste to it, you can be walking down the mine, you can walk into an area without methane, with methane in it, and that methane has replaced the air. And so as you walk through it, you don't realize that you're walking into an area that has no air in it anymore. And of course, you begin to suffocate, you pass out, and it can lead to death. Methane is also highly flammable, and so if there is an area of your mine that has a buildup of methane and you happen to produce a spark, it can lead to an explosion, which is obviously very serious. The other thing about coal bed methane is that it makes a significant contribution to the amount of methane that goes into the atmosphere. And so this is obviously bad because of global warming. So in terms of collecting coal bed methane, it can be done. You use a process similar to fracking. So you're going to put small boreholes in, you're going to fracture the coal, and that's going to allow the methane to escape and you can collect it. However, under most circumstances, it is not particularly economically viable. So the vast majority of methane that is identified or can be extracted from these bituminous coal seams will often be burnt on site in order to remove it and destroy it. So bituminous coal forms at temperatures between 85 and 235 Celsius, and this is sufficient to allow some of that organic material to break down to form bitumen and also to form some methane. And it's going to occur at depths between 2.5 and 6.1 kilometers. So this kind of coal is forming quite deep. And so if the overburden happens to have been eroded away, then great, you can access this particular type of coal through open pit. However, there are also some mines which will access this type of coal through underground mining. In terms of underground mining methods, underground mining tends to be way more expensive than open pit mining. And so if you are going to mine bituminous coal underground, you need a very large deposit which you can mine cheaply because it's not a high value material. People aren't going to pay a lot for bituminous coal. So if you are going to mine it underground, you need to mine it super cheaply. Okay, so once we have our bituminous coal and we start to bury it deeper, so we expose it to even higher temperatures and pressures, what's going to happen to it? Well, we're going to end up forming anthracite. So anthracite is the highest grade of coal, and it contains between 86 and 97% carbon. So it's about as pure as, in terms of carbon, it's about as pure as you can get before you hit graphite. Now, anthracite is used mainly for power generation. However, the fact that it has so few impurities means that it can also be used as a domestic fuel. You can burn it in your home fire and it won't produce a whole lot of smoke as a result. It tends to form at temperatures in excess of 235 Celsius and depths in excess of 5 kilometers. So it tends to form very deep. Now, the depth of most anthracite deposits, because most of them are underground, and the fact that anthracite is considerably harder than bituminous coal means that it's typically 6 times more expensive to mine anthracite than it is bituminous coal. And so even though anthracite is undoubtedly the better coal to use because it is way less polluting than bituminous coal, it is also considerably more expensive to produce. And so this means that although anthracite is the better coal, it's typically not used in things like power generation. It's just too expensive. Now, there are some places where anthracite is mined cheaply enough to allow it to be used in processes like power generation. But these tend to be mines in much lower cost countries. So we're looking at places like China and Vietnam. And because they are lower cost countries, it means the cost of production is going to be considerably lower. And so the anthracite can be extracted and burnt and it's not too expensive. So in terms of how we mine coal, how is it done? Well, the nice thing about coal seams is they're a layer of rock. So that means you can just mine that layer. And so you will use special pieces of equipment that will allow you to mine and just follow that layer as easily as possible. So on the left-hand side here, we have a picture of a coal mine. And this is actually the mine itself right here. This is where the coal is being stored. And right next door to it, there is a power plant which is burning the coal produced. Because why transport it? Coal is heavy. It's just easier to build the power plant right next to the coal mine. Then you can burn it there and you don't have to pay the cost of transporting the coal. In terms of the coal mine itself, it's going to look something like this. And you can see here, this is actually the seam that's being exploited. Now, because coal is a cheap bulk resource, you've got to mine it as cheaply as possible. And so this means that whatever mining method you use has to be the cheapest one you can achieve. And so it's not uncommon to, first of all, mine coal using open pits because they are the cheapest method of mining. And you will typically use very large pieces of equipment so that you can extract a large amount of coal in one go, because once again, you want to do it as cheaply as possible. And so you will use pieces of equipment like this. This is a drag line. It's a type of excavator. And essentially on the end of these ropes here, you're going to have a giant steel bucket, which gets winched up, it gets released, it drops under gravity, and it smashes into the coal seam. And it essentially breaks up the coal seam and a load of the coal goes into the bucket, and then the bucket is winched up and emptied, and then it's done again and again and again. And this is a very efficient method of mining because gravity is being used to actually swing the bucket down to extract the coal. So as underground mining is more expensive than open pit mining, you need to mechanize it as much as possible to keep costs low. So the majority of underground coal mining is going to use what's referred to as the long wall mining method. So this is going to require you to dig down until you reach your coal seam. And once you reach the correct level, you are going to then cut, extract, excavate a big, long room, sometimes referred to as a stope. So within this long room, one of the walls of it is going to be your coal seam. And along the length of this room, you are going to set up some tracks. And on those tracks, you are going to put a special piece of grinding equipment. And this piece of grinding equipment is going to go up and down along the tracks that you lay down. And it's going to grind away at the coal face, causing pieces of coal to fall off. And when those pieces of coal fall off, there will typically be a conveyor belt located in that area, and the coal will fall onto that conveyor belt and it can then be transported back to the surface. So it's called the long wall method because the stopes which are cut in order to extract the coal are very long and very narrow, and that explains the name. So underground mining, like any form of mining, once you go underground, you have to do it as cheaply as possible in order to compete with surface mining. Okay, that's it. Thank you for watching.